Yesterday we talked about water treatment and wastewater treatment, and we began to look at different types of pollution. And the first way we classify pollution is it a point source or a non-point source pollution? And then we look at the different categories of pollutants. Human waste can be a pollutant, industrial waste, chemical runoff, and then we looked at, you were asked to read about some different solutions for cleaning up different types of pollution. Today we're going to look at some specific definitions related to water pollution and some examples, and we are also going to talk about some water quality indicators, things that help determine if the body of water is healthy or not. So the first thing we want to look at is the definition of water pollution itself. And that is the addition of any substance that has a negative effect on the body of water and the living things in the water. So it's just as important to how it affects the fish and the other organisms that live in the water as well. And potable water, is it available, is it clean enough to drink, is all going to depend on the quality of this water. Is it negatively affected or not? So yesterday you read about treated wastewater, you read about runoff, toxic chemicals, municipal sewage, motor oil from cars, fertilizers, detergents, and pesticides, all the different things that can get in our waterways and create problems and have a negative effect. When waste is deposited in water, and we're talking about human waste or animal waste, solid particles will settle to the bottom because they are heavier than the water. And if it is a chemical waste, any kind of toxin, anything like that, over time it gets diluted in strength by the water. And water has the ability to naturally renew itself through the water cycle: evaporation, precipitation, condensation, filtration through the wetlands, filtration through groundwater. But unfortunately, we're adding more and more waste and more chemicals into our water, and it is reducing the natural ways that water can renew itself and clean itself, and it's reducing the quality of water because it can't clean it up. And then we have water treatment and wastewater treatment to help clean it up, but again, it's still not getting out everything. Nutrient waste is waste that is caused by animal poop or human poop getting in the water. And nutrient means it is feeding the plant matter in the water. And if you have too much plant matter in the water, the algae begins to grow out of control, and the body of water will take on a green cast in many cases, and we call that nutrient matter. And that's going to create a lot of decay, because you're going to have so much plant matter, you're going to have more plant matter than the fish can eat, and so it will die quickly and decay quickly and settle to the bottom and act as fertilizer again to fertilize more plant growth, and it creates this cycle of nutrient waste in the water. And when the lake, pond, or stream gets overtaken by algae, there's just way too much algae in it, and it has this green scum-like effect covering the surface. That's going to choke out all oxygen from entering the water. Because you've got so much decaying plant matter in the water, you're going to have a lot of bacteria action, and the bacteria are going to take what oxygen is in the water for their processes, and therefore fish are deprived of dissolved oxygen in the water, and you will have fish kills in many places where eutrophication takes place, and essentially the body of water becomes a dead zone. So as you can see here in this diagram, you have this oxygenated water. It's on top. You've got a lot of nutrient matter. You get this algae layer that blocks the oxygen flow to the lower water, and so you're going to have a mortality, a high death rate for things that live below, and over time it will become a dead zone. We have sediment pollution, which is the #1 cause of water pollution in North Carolina's rivers. What has caused our sediment runoff? Primarily, we had rapid growth in the 80s and the 90s in the urban areas: Charlotte, Raleigh, Durham, Cary, Chapel Hill, And we did a lot of clear cutting, cut down all the trees to build giant neighborhoods and shopping centers and apartment complexes. And in the months it took to build those buildings, every time you had rain, sediment ran off and settled in the water. How does this harm water quality? It makes the water very cloudy. It adds another layer of sediment when it settles to the bottom of the river and the stream. It buries the organisms that live on the bottom. It buries their eggs again, and they may not hatch. And so it creates some problems. This is called turbidity, when the water becomes too cloudy based on sediment and other solid particles going in the water. Effluent is a term that describes any kind of waste: chemical waste, human waste, animal waste, soil waste. Anything that goes in the water is waste material, and then or gets discharged in the air from a smokestack. All of that is called effluent. The two major categories we use when we're talking about pollution is how it gets in the water. Can I track back who's to blame? Is it point source? Can I trace it or point a finger at the person who is responsible or the company who is responsible? So ask yourself when trying to consider this. Point source pollution is something that's coming out of a pipe. I can trace that pipe back to a factory or a business. A smokestack, same thing. A culvert, which is just an underground pipe. Underground containers, if they're marked Acme Chemical Company. Anything of those kind of things that are leaking or pouring smoke, wastewater, storm sewer wastewater into a body of water, I can track back and find out who's to blame. Non-point source pollution, I can't ever figure out who caused it. Your car exhaust, you drive down the road, exhaust comes out of your car because your muffler's not working. Your oil is leaking because you need to have some repairs. Heavy rainstorm, you drive down I-40, you leak exhaust, you leak oil. It all settles down on the highway. We have 10 inches of rain tomorrow. It washes into the stormwater sewer and ends up back in Crabtree Creek. Who's going to ever know where that oil or carbon monoxide came from? Never trace it back to your car. Salt, after a winter storm, runs into the river. A boat out on enjoying a day on the lake or a day on the sound, and they empty their little mini toilet canister overboard. Are we ever going to find out who caused that? Non-point source pollution. Now, when chemicals enter the environment through the groundwater or surface water, they can also enter the food chain. Anytime a chemical gets in the food chain, it's going to do more harm to the health of the organisms at the top of the food chain. Bio means living, magnify means greater effect. So at the top of the food chain, you are going to have the highest amount of damage to the health of the organism. The first level producers, or the plants, are going to absorb the chemical. The small consumers are going to eat those plants. They're going to absorb the chemicals. They're going to have to eat a lot of plants to get their nutritional needs, and that chemical cannot be digested, so it will absorb and stay in their tissue. Then a larger second level consumer will eat the first level consumer. Again, it's going to take more food to feed it, and again, they can't digest the chemicals. They'll stay in their tissue. And finally, you get to the organism at the top of the food chain, and the percent of chemical that is now in their body tissues, again, still hasn't been digested, is greater. And the best example I can give you of this happened with a chemical called DDT. DDT was a pesticide. It was developed by the Monsanto Corporation in the 1950s. They said it would break down quickly when it ran off crops after rain, and it would do its job in the field, and then it would break down quickly and cause no harm. Well, that appeared to be the case at first. People were buying it worldwide. They were selling it. Every farmer in the world was using it. And then all of a sudden, a scientist named Rachel Carlson and some others noticed that the bird populations were declining. And when they began to figure out what was happening, they noticed that all of these were birds that ate food out of lakes and rivers and streams, like ospreys and eagles. They also found that the parent didn't seem to be ill health, but that the mother was laying eggs without shells. And if you know anything about how eggs of a bird are incubated, the mother or the father sit on the nest and keep the eggs warm while the birds are developing. And without a shell, they were destroying the embryos. And when they examined the tissue, they found that the ospreys and the eagles had 25 parts per million DDT in their tissues, whereas the phytoplankton, the plant producers in their food chain, look at how small the number is. That is 3/10, 100, 1,000, 10,000. 3 parts per million of the DDT. And then the zooplankton, which were the tiny animal-like organisms that ate the phytoplankton, they had 4/100 part per million. Small fish had 1/2 part per million. And then the larger fish were having 2 parts per million. And then in that largest organism, the osprey and the eagle. And that was, DDT was impacting the reproductive organs of the female birds. Several shorebirds became extinct. Several others' populations declined. The eagle was on the endangered species list for many years. So there was a negative impact of the pesticide. Now, how can you determine if the water is healthy? What's its water quality? Is it a healthy body of water? Is it an unhealthy body of water? Is it at risk? Well, the first thing you want to see is how many living organisms are in there. You're looking for bioindicator species, which are usually small insects and amphibians. Macro means large enough to be seen. Invertebrate means without a backbone. And so this would be all your crustaceans, your crayfish, your mayflies, your dragonflies, insects that live around water, as well as amphibians. They are very sensitive. They are pollution intolerant. And because they are pollution intolerant, if the water is not healthy, their populations are going to go down. So that's one of the first things a water biologist would do, is go just count populations of these bioindicator species. Then you would measure how much dissolved oxygen is in the water. Anything that has gills, fish, for example, have to be able to draw the water in through their gills and remove the dissolved oxygen from the water to carry out respiration. So dissolved oxygen is the #1 indicator of how healthy the body of water is, because the living things in the water that are in the animal kingdom, or the protist kingdom, or the fungi kingdom, have to have a steady supply of dissolved oxygen. Phosphates and nitrates are chemicals that do not belong in the water. And so if their concentration is the least bit high, then that indicates that the body of water is polluted. It can be caused from chemicals such as fertilizers, detergents, carry both phosphates and nitrates, mammal waste. So if cow poop or pig poop or human sewers are leaking into the body of water, you're going to have high concentrations of nitrates. And these chemicals act like a fertilizer to all the algae and plant populations, leading to excess growth. And we talked about eutrophication a few slides ago. And so it can lead to a dead zone in the body of water. If nothing more, if the concentration is too high, you'll have a fish kill. They're very common in the summer in polluted waters. Temperature is a good indicator. There's an ideal temperature range. What species who live in the lake, in the stream, in the river can survive. So, there's a cold winter temperature up to a summer temperature. And if you exceed that summer temperature due to some of these thermal pollution or heat pollution, which can happen from factory waste, then that can create a problem for species. Turbidity, we mentioned sediment pollution being a problem in North Carolina rivers, and turbidity is a measure of how clear the water is. If it is not transparent, if it's least bit cloudy, it's got suspended particles like clay or different soil types in it, And the more of that you have, the more turbid the water is, the more likely you have had some type of impact on the benthos or the species that live on the bottom, like your crayfish. pH is a measure of how acidic the water is, or the opposite of an acid is an alkaline. So all of your cleaning products and detergents are alkalines, acids, hydrochloric acid, carbonate acid, sulfuric acid, things that are used in manufacturing processes. If they end up in the water, you can create fish kills as well. 0 to 7 tells you acid, with 0 to 1 being the strongest acid. 7 is neutral. 8 to 14 is basic, so an alkaline, more of a cleaning product. Water should be around 7. Ideally, it's about 7.2. Healthy stream, maybe up to 8, safe. You don't want to get down the acid range at all. You don't want to get much above 8, or it's going to be unhealthy for many species.